We have a semicircle with diameter AB. On the curved edge of the semicircle are 2 points, C and D. We are given 2 important clues. First, line segment AD is exactly the same length as line segment DC. Second, angle ACD measures exactly 37 degrees. Our mission is to find angle X, which is angle CAB. Let's start with triangle ADC. Since AD and DC are equal, this is an isosceles triangle, and that immediately tells us something important. The angles opposite those equal sides must also be equal. Since angle ACD is 37 degrees, angle DAC is also 37 degrees. Now finding the third angle is easy. The angles of every triangle add up to 180 degrees. 37 plus 37 equals 74. So angle ADC is 180 minus 74, which gives us 106 degrees. Now comes the key move. Let's draw one extra line connecting point C to point B. That single line unlocks 2 powerful geometry theorems. First, the angle in a semicircle theorem. Because AB is the diameter, angle ACB must always be a perfect right angle. So angle ACB is exactly 90 degrees. Now look at the larger shape. Points A, B, C, and D all lie on the same circle. That means ABCD is a cyclic quadrilateral. And every cyclic quadrilateral has a beautiful property. Its opposite angles always add up to 180 degrees. We already know that angle ADC is 106 degrees, so angle ABC must be 180 minus 106, which is 74 degrees. We're almost there. Now look at triangle ABC. Its 3 angles must also add up to 180 degrees. We already know 2 of them. Angle ACB is 90 degrees. Angle ABC is 74 degrees. So the remaining angle, our mystery angle X, is simply 180 minus 90 minus 74. That gives us 16 degrees. So the exact value of angle X is 16 degrees. And that's the entire puzzle. If you enjoy geometry puzzles like this, don't forget to like the video, subscribe, and I'll see you in the next one.